This question is from GATE 2021 Mechanical Engineering paper set 2, question number 41. The thickness, width and length of a metal slab are 50 mm, 250 mm and 3600 mm respectively. The rolling operation on this slab reduces the thickness by 10% and increases the width by 3%. The length of rolled slab is dash millimeters. Let's find out. We'll write the given things. Initial thickness is given as 50 mm. Initial width is 250 mm and initial length is 3600 mm. It is given that thickness decreases by 10%. So we can write final thickness is 0.9 times the initial thickness. How we get it is by doing 100 minus 10 by 100 into Ti. Similarly, final width BF is increasing by 3%. So this should be 1.03 times Bi. We need to find out what will be the final length value. We know that volume will remain same for the slab. That is, Vi, initial volume, will be equal to the final volume. Initial volume can be written as Li into Bi into Ti. Because this is slab given, the geometry is cuboidal. So we take the volume as length into breadth into thickness. Will be equal to, let the final length be Lf. Final width can be written as 1.03 times Bi and final thickness can be written as 0.9 times Ti. So we can divide both sides with Bi and Ti. What remains is the final length Lf will be equal to Li upon 1.03 into 0.9, which will be equal to 3600 divided by product of these two terms is 0.927. We have the answer of final length as 3883.5 millimeters. Let's go back and fill in this answer. Length of the rolled slab will be 3883.5 millimeter. We have already rounded it off to 1 decimal place. To learn more about rolling, you can refer to the NPTEL video, Metal Working Processes Rolling. It's from the course Fundamentals of Manufacturing Processes. The course is taught by Dr. D.K. Dwivedi. He is from Mechanical and Industrial Engineering Department of IIT Roorkee. I hope the solution helps you clear your doubt. Thank you.